So, proofs. In my experience, a lot of people struggle with proofs because they get what I call proof block, which is akin to writer's block. How do you avoid proof block where you just stare at the proof and you want to give up and say, I don't even know where to start? The first thing you do is you always focus on the given. Always focus first on the given and use each piece of the given. As you use a piece, if you want, go put a little check mark next to it when you're done saying, hey, look, I've used that. Almost all the time, if you've used it once, that's as much as you're going to use it. Once in a while, if you're given like a parallelogram or a rhombus or something like that that has more than one property to it, a rectangle, then you might use it more than once. But generally speaking, if it has anything to do with a normal phrase like midpoint, bisector, we said midpoint, bisector, isosceles, vertical angles, and so on, then right angles, you normally use it just once. Okay, so last week we started talking a little bit about the Cpctc, which means corresponding parts of congruent triangles are congruent. And the big thing I want to emphasize here is it's the corresponding parts of the congruent triangles, which means you need to get congruent triangles first. So all of the stuff we just did, SAS, SSS, ASA, AAS, all of that has to come first, then you can go to Cpctc. I personally get very upset as a teacher if a student ever used Cpctc before they proved triangles congruent. I used to get like really nasty about it. It was like the one thing that drove me nuts. So that means you completely didn't understand anything about proofs. Corresponding parts of congruent triangles are congruent. So first you have to get the congruent triangles. What's our strategy? Step one, look at the given, use every piece of the given. Then we start looking at vertical angles. We start looking at reflexive, which is whenever they share a side or an angle in common. And then we think about, if those aren't there, linear pair and supplementary. And I think we'll address each of these before the end of class, end of the 2 classes this week. So here is our first proof to do. And what I would like you to do is start with the given, use each piece of the given, then look at the diagram and see if you can find reflexive or vertical angles or linear pairs. And then finally, or 2 pairs of linear pairs. 1 pair is not enough. And then put your proof together. So go ahead, do that. And I will, we'll do one other in this particular video, then we'll get started on the next section. Okay, so B is the midpoint of AC, BD is perpendicular to AC. So the first thing I want to use is midpoint. And when I use a midpoint first, that means that B is the midpoint. So the 2 pieces from A to B and from C to B are going to be congruent to each other. And that's because a midpoint divides a segment into 2 congruent segments. Now, it's extremely important that you then mark the diagram, and you can see the marks that I just made there. They're critically important because those were the marks that we had before when we were looking up side, and angle, side, angle, and so on and so forth. So, all right, the first piece of given said midpoint. I used midpoint. What does the next piece say? The next piece says perpendicular, so let's use perpendicular. It says angle 1 is congruent to angle 2. These boxes, ignore the arrows. The boxes are the symbols for perpendicular lines. So angle 1 is congruent to angle 2 because perpendicular lines form congruent right angles. And that's what they do. Perpendicular lines make right angles, and every right angle on the planet measures 90 degrees. So they have to be equal. Okay, I can check off that one. I did that. Good. Now, I used up the given. Look at the given here. I put a little check mark next to midpoint because I use that. I put a check mark next to perpendicular, so I use that. Now, I'm going to look and stare at the diagram. So many students, they immediately stare at the diagram and they're not paying attention to the given. So they're missing all of the information the given is supplying to them. And the person who made up the question gives you the given. That's why they come up with the word given. so that you can get the proof right. So that has to be your first focus. The given, we've used it, we're in good shape. By the way, proofs like this tend to be partial credit proofs. And the minute you use up all the given, you've probably gotten half the credit, maybe even a little bit more. Like if it's worth 10 points, you've probably gotten 6 out of 10, maybe even 7 out of 10. Okay, so what do we look at next? I look for vertical angles, I look for reflexive, and I look for linear pairs, 2 pairs of linear pairs. And what I see here is a reflexive. I see that the side BD is shared by both triangles. So step 4, BD is congruent to BD by reflexive. And step 5 then is that the 2 triangles are congruent. And the reason they are congruent is side angle side is congruent to side angle side. Now, that's where we ended up last week. And we did proofs very similar to this last week. Oh, by the way, with reflexive, I always put an X there to note reflexive. The big step up this week is that you're asked to prove a second thing. You're asked to prove angle A is congruent to angle C. After we prove the triangle's congruent, we always then go to the parts that we want to get. We've shown the whole triangle is congruent to the whole triangle. Now we go to the parts, and they're congruent by Cpctc. Okay? All right, let's do one more proof on this particular video. Very similar. Go ahead, stop and start. Okay, so first thing we look at is the word bisects. It says DB bisects AC, so AB is going to be congruent to BC or CB because a bisector divides it into 2 congruent segments. Next, we see perpendicular. So I start talking about right angles. Angle 1 is congruent to angle 2. Why? Again, perpendicular lines form congruent right angles. Now, I've used up all the, oh, I almost forgot to mark it. I got my marks, I got my angles. What do I have next? Well, I've used up all the given. So now I look for reflexive, I look for vertical angles, I look for 2 pairs of linear pairs, and I only see a reflexive DB down the middle that they share in common. So BD is congruent to BD by reflexive. Remember, reflexive means anything is equal to itself. So that means that, and I should have put an X here. I did it actually on the next step. There's the X. I now have a side, BD running down the middle, an angle, 1 or 2, and then a side where the hash marks are. So ADB is congruent to CDB by, the angle is between the 2 sides. So it's side angle side is congruent to side angle side. And now the next step of the proof, I don't even really need to look at the proof. I know they want the triangles congruent. Then I peek afterwards and say, okay, what else are you looking for? You're looking for AD congruent to CD. In other words, these sides out here. And they're going to be congruent because they are the corresponding parts of the congruent triangles, which I always prove congruent by Cpctc. And that is the completion of the proof. All right, so there are 2 good solid proofs for you, and we got some more to do in upcoming videos.